Okay, so let us start the class. Good morning. So let's say I am moving here with velocity 10 meter per second. This is my velocity. When I don't mention with respect to what, it should be understood it is with respect to ground. And let's say you are going with velocity 10 meter per second in this direction. If I ask what is my velocity with respect to you, then what is the formula? My velocity with respect to ground minus your velocity with respect to ground. This minus is by default in the formula. Don't think there is minus sign because this is opposite to this. Minus is by what? Default. It is already there in the formula. Now if you put 10, 10, what will you get? 0. Right or wrong? Wrong, because this is actually what equation? Vector equation. So my velocity is where? 10 I cap. Your velocity is where? 10 j cap. So this is my velocity with respect to you. In what direction it will be if they ask? Draw x and y. So my velocity with respect to you has x component 10, y component minus 10. Minus matlab direction is down. Length will be 10 only. Add those two. Because this is basically addition of this and this. No. Matlab this is 10 I cap plus minus 10 j cap. So you have to add this vector with this vector. You already know how to add vectors. So this is the velocity of mine with respect to you. Magnitude, if they ask how much it will be? 10 root 2. Direction, if they ask 45 degree with x axis, but in this direction. So this you already know, right? Then I told you, suppose somebody throws me from a building and somebody throws you also from the building. Now as I am falling, you are falling under gravity. My acceleration with respect to you will be what? My acceleration with respect to ground, which is g. Your acceleration with respect to ground, which is also g. We are falling freely. So what is my acceleration with respect to you? 0. That means my velocity with respect to you will be what now? Constant. And if velocity is constant, you will always see the body moving in a straight line. So this is very, very advantage to discuss or to find time of collision between two bodies which are moving in space. So last time I discussed the theory, I wanted to do one problem based on that, numerical problem. So here are two buildings separated by 50 meters. Please write with me. This building is 100 meter. This building is 60 meters. A particle is thrown from here horizontally with velocity 5 meter per second. And another particle is thrown from here at an angle 45 degree but with unknown velocity. Your job is to find this velocity, matlab direction is 45 degree, so you have to calculate only the magnitude. So you have to find u so that they collide. If they ask find u so that they collide, they may also ask when and where they collide. When and where. When and where matlab time and coordinates. Time and coordinates. Now, actually how the motion will look from ground frame if they collide. This will follow parabola, this will follow parabola. So somewhere here they may collide, somewhere here they may collide, depending on the speed and all. So wherever they collide, the path will look like this, which is complicated when you see from ground frame. But here we will use one brilliant idea that if two bodies are moving only under gravity, one body will always see other body moving in a straight line. Because relative acceleration is zero, relative velocity is constant. So the advantage is if you do the problem from with respect to, let's say, this particle. So let me solve the problem from this frame of reference. That means now, because I am doing the problem with respect to B, B will be at what? Rest. Now if B is at rest, if B is at rest and A is moving in a straight line, A has to move in a straight line now, because we are doing the problem with respect to B. Then A has to move this way in order to collide. It has to move straight like this. So the velocity of A with respect to B has to be where? In this direction. Now how to find velocity of A with respect to B? Reverse velocity of B add with A. A already has velocity this side. B has at angle. So let us take components. So this U will have one component U by root 2. One component U by root 2. I hope you understood. U cos 45, U sin 45. Reverse this two and add with this. So what will be X component of velocity of A? 5 this side. If you reverse this one, it will be U by root 2 that side. So if you add, they are in what direction? Same. So what is the velocity? 5 plus U by root 2. This is with respect to B. What will be Y component? You have to reverse these two components. So U by root 2 will be added here. So it will be U by root 2 down. What plus? What will you add? This doesn't have Y component of velocity. That means this is the X component of whose velocity? A with respect to B. This is the Y component of velocity of A with respect to B. So the vector should be such that if you add those two, the resultant should be here, right? So this will be velocity of A with respect to B. So how to find now? If I draw this line, so how to find U now? Very simple. Let me call this angle as phi. And this angle is also phi. Now I can find this phi in two ways. One is tan phi is equals to, from this velocity diagram, tan phi, opposite by adjacent. Opposite is what? U by root 2. That you know, na? If a vector has Y component, X component, how do you find tan of angle of that vector? With X axis. Y component by X component. So with X axis, this is X axis, you imagine. So this velocity makes angle phi with X axis. So what will be tan of that angle? Y component by X component. Y component matlab opposite side, X component means adjacent side. So U by root 2, 5 plus U by root 2. That is one way of calculating tan of angle. Another way of calculating tan of angle is from this building. Because this side will be 40. This side is 50. So what will be tan of phi? 40 by 50. Yes or no? Now you can easily solve. 0, 0 cancels. If you simplify this, it will be U by 5 root 2 plus U. Root 2 in denominator will cancel. This will be 4 by 5. How much it comes? Cross multiply. 5U is equals to 20 root 2 plus 4U. So U will be what? 20 root 2. Luckily, nice number came. Yes or no? Now if they ask time of collision, then what will you do? You have three options. Divide this displacement by this velocity, or this displacement by this velocity, or this displacement by this velocity. Because there is no acceleration if you sit in which frame? B's frame. If acceleration is not there, displacement along x will be what? Vx into t. So when the particle reaches here, what is the displacement actual? This is the actual displacement. What is the x component of displacement? 50. Y component of displacement? 40. So x component is 50. What is the velocity of the A with respect to B? Here, what is x component? 5 plus u root 2. 5 plus u by root 2 into t. T will be what? Time of collision. Time of collision is independent of frame of reference. So if you put 20, u is how much? 20 root 2. What is the answer? 2 seconds. Where they will collide, how will you find? Now you have to come to ground frame. Now you have to come to ground frame. Because they are asking where they will collide. So you have to come to ground and see. So that is easy. So let's say here they collide. So if you focus on this particle only, initial velocity of A was this side how much? 5. So now think of A as projectile motion from here to here. So this is your Sx for particle A. This is your Sy for particle A. And time of collision is how much? 2 seconds. That is independent of frame of reference. So let us calculate Sxa. Sxa matlab x component of displacement of A when it collides. So that will be ux of A into t. No ax. But sir, now we are doing from ground frame. That doesn't matter. From ground frame also, acceleration due to gravity is only along y-axis. What is ux of A? Not this one. This is ux of A with respect to B. Now we have to come and do the problem from ground frame. 5. After what time it collides? 2. So 10 meters. 10 meters or centimeters? This was given in? Velocity was given in? This was given in meter, centimeter. And how this is centimeter here? Luckily, while taking ratio, it got cancelled. So it doesn't matter here. Here it will matter, no. So 10 meter means where? Here it will collide somewhere in this line. And y component of displacement for A, uya t plus half aya t square. Uya is 0 because A was thrown horizontally. Downwards, let us take down positive. So ay for acceleration of A is g. Time taken is 2t square. So how much? 20 meters. So where it will collide? 20 meter this side, 10 meter this side, 20 meter this side, remember, okay, because we have taken down positive and we have started from here. So if you want to really see where they collide exactly, so this is A, this is A. From A, if I measure, it collides 20 meter down, 10 meter this side. That means if somebody puts origin here, let's say, in exam they can put origin wherever they want. So if they put origin here, then what will be coordinate of the point of collision? What is x coordinate? 10. Why centimeter I am writing my every time? What is y coordinate? Huh? 20, This is origin I told. Huh? Online scolding you want, What is the whole height? How much displacement it has? 20 down. So 80. Let me tell you what is the condition for collision in terms of velocities and position vectors. So let's say this is your origin and these are two particles. This is position vector of first particle. This is position vector of second particle. Now they have some velocities. I don't know where the velocities are. Randomly let me write VA vector, VB vector. Question is, what should be the relation between these vectors so that they collide? Simple. To collide, what I told? To collide, what I told? If you are sitting here, if you sit here, you should see A coming this way, isn't it? Assuming there is no acceleration in this problem. Otherwise, it may turn and come also. Like in that triangle problem yesterday I told, no? Like this. So that time, even if you sit in one particle, it will still come and collide like this, not straight. But here let us assume no acceleration, relative acceleration 0 you think, like two projectiles. Then you have to see this coming this way, meaning the velocity of A vector with respect to B. Velocity of A vector, why I told. Velocity of this body with respect to this should be here. Then only pakka they will collide. Now this is RA vector. This is RB vector. And who knows what is this vector? RB minus RA vector. Resultant, difference. This plus this is this. So this vector is this minus this. That day also I told you, if you join the heads of two vectors, you always get difference of the two vectors. If the vector is this side, this minus this. If the vector is this side, this minus this. In other words, where should be the relative velocity? In the direction of this. That means unit vector in those two directions must be same. So unit vector in this direction will be what? VAB cap must be same as this cap. What shall I call this vector? Let me call RBA vector. Then it should be RBA cap. So unit vector of this and this should match. Then only this will see, this one will come and collide. What is VAB cap? VAB vector by mod of VAB vector. And what is RBA cap? RBA vector by mod of RBA vector. And VAB vector is what? Velocity of A minus velocity of B. Mod of VA minus VB. And this is RB vector minus RA vector by mod of RB vector minus RA vector. So the important thing is this, if this is A, this is B, this is B, this is A. Some of them may write A and B only, but they will put a what sign here? Minus. So students, we have calculated till now how to find relative velocity of one body with respect to another body. What we should do? Reverse the velocity of second body at with first velocity. But sometimes we will be given relative velocity. We will be given relative velocity. We will be asked to find ground velocity. Ground matlab velocity of the body with respect to ground. Example, let me tell. Suppose this is a bus. Okay, I am sitting in this bus and after some time I am bored. So I run inside the bus with velocity of Pankaj with respect to bus. So this is how much distance I cover inside the bus. Imagine this room is bus. Imagine this room is bus. I cover like this. Whatever distance I covered, that is with respect to ground or with respect to somebody looking at me inside the bus. Somebody inside the bus. So that displacement by time will not give me my velocity from ground. That is my velocity with respect to bus. Now if bus is not moving, then this is also velocity of Pankaj sir with respect to bus, with respect to ground. That's why we call this velocity of Pankaj sir, velocity of Pankaj in still bus, still rest bus. So if bus is still, then this is also my velocity with respect to ground. But if bus is moving this side, now what will be my velocity when you will see from outside? V? No, that you have to say later. Velocity of Pankaj sir with respect to bus plus velocity of bus. So what I am trying to tell is sometimes we need to know relative velocity. Sometimes we will be given relative velocity. This will be given. They will tell Pankaj sir can walk this much in the bus or Pankaj sir can swim this much in the river. That is my velocity in still water. But if water also moves, then ground people will see me moving maybe more faster or maybe more slower or maybe at different angle. So please understand this vector equation, but here both of them were in same direction. So I was able to just add them. If R bar is A bar plus B bar and these two are in same direction, what is the resultant magnitude? A plus B. So this also you try to remember, okay? Acha, can you tell me one thing? Out of these three velocities, which one depends only on my strength? My strength. Which one depends only on my strength? V? P. Why? Suppose I'm dead. I'm dead inside the bus. Ground people can see me moving or not. So VP will be there, no? VP will be there. Even if I am dead inside the bus, I will be simply sitting like this. But ground people will still see me moving because bus is moving. So I asked you which out of these three depends only on my velocity, my strength, whether I am walking or not walking. It is V, PB. This one is controlled by only my strength. This is controlled by my ability. So this is called velocity of Pankaj sir in steel bus, or sometimes they say when a man is swimming in water. If you want to know velocity of man from ground, then what you have to do? Velocity of man in still water plus velocity of water. Are you understanding? Water is like the bus now. Which one is controlled by your muscles? This is controlled by your muscles. That's why when we do Olympics, we keep the water at rest or we allow the water to move? Rest. Because your ability should make you win or lose, not water's velocity. Yes or no? So this velocity is controlled by your muscles. Of course, this one will depend on your muscles also and water's velocity also. This will depend on both. But this will depend only on your ability. That's why it is called man's velocity in still water. So if water was still, how much you can swim? That speed is fixed based on a person. For one person, that speed is fixed. Of course, next year you can become little bit stronger and you can change it. But that moment you cannot change. No. That moment only you will become super fit. How? But this can add to your velocity to give you resultant velocity which is with respect to ground. So this is what ground people will see, remember. Okay, so later we will discuss river board problems. Let us now discuss problems where relative velocity will be given. We have to find velocity from ground. So see this question, all of you. Imagine this is a big ship. Okay, moving in this direction. Velocity of the ship is, let's say, 10 meter per second. In the ship there is a car which is going this way. It is going this way, matlab inside the boat. If this was the ship, if this room was the ship, car is moving this way. And that velocity of the ship that they give is with respect to whom you should think. Ground or ship? Ship, because it is moving in the ship. So how much displacement it moves in the ship divided by time will give you velocity of ship with respect to, velocity of car with respect to ship. So this is velocity, though they may say like this, velocity of car in the ship is this much. You have to understand it is with respect to ship only. Let's say 5 meter per second. Now in the car there is a vertical pole. To remind you this is vertical, let me put clouds here and birds are flying. Now you will understand it is vertical. In this pole there is a monkey. I said monkey. Why are you feeling bad? Okay. It is going vertically up with velocity 3 meter per second. What do you think? Whose velocity is this? Of course monkey's. But with respect to whom? Car. Because he is walking in this pole. And that pole is fixed in the car. So if car was not moving, everybody would have seen this velocity. Matlab it is velocity of monkey in steel car, like that. Just now I explained steel concept. So this is velocity of monkey with respect to car. What they will ask? Find velocity of monkey. If I don't say with respect to anything, it means from ground frame. From ground frame. How will you do? One person told like this, 10 plus 5 plus 3, 18. They are all in same direction. So what we should do? Velocity of monkey will be what? Velocity of monkey with respect to car plus velocity of car. All are in vector form, remember. Then velocity of monkey with respect to car. Velocity of car will be what? Velocity of car with respect to ship plus velocity of ship. What is velocity of monkey? If car was not moving, 3. Up, matlab I will write k cap. I will write x here, y here, z here. So this is 3k cap. Where is velocity of car with respect to ship? 5j cap. And velocity of ship? 10i cap. So this is velocity of monkey. If they ask magnitude, under root 3 square plus 5 square plus 10 square. End of story. Okay, you only tell me. Suppose you are a bad person running away. No, not you. Why should I do? Suppose there is a bad person and he is running away from police in a bike. And he sees bullet is coming. He sees what is coming? Bullet. For him, which velocity is important? Velocity of bullet with respect to ground or velocity of bullet with respect to thief? With respect to thief or with respect to ground? Thief, because that velocity will control whether he will get hit or not. If bullet is coming 100 meters per second and thief is running 100 meters per second, I don't know, some rocket kind of bike he has, then he will not worry. He will say, come, I am also going with same velocity. Relative velocity will be 0. So you have to understand such concept, because they will not sometimes tell directly they want velocity of bullet with respect to thief. They will say find the velocity with which the bullet hits the thief. Hits the thief. Hits the thief matlab what? With respect to thief, bullet should come. Understood? So see this nice problem. There is a police in a jeep and the velocity of police is given, let's say 5 meter per second from ground frame. Now normally they will give in kilometer per hour. I hope you can convert into meter per second. Now here there is a thief in a bike and thief is running away with velocity 30 meter per second. Puncture happened for some reason for the police Otherwise, our police would have easily catched. Okay. So now he cannot catch him with this velocity, so he makes use of gun. So he takes out his gun and he fires bullet with velocity 120 meter per second. Now you have to understand the meaning of this. They will say like this: bullet is fired with velocity 120. But that is velocity of bullet with respect to whom do you think? Police. That is important. Because if he says fire, he should see bullet going. Ground people was anyway seeing the bullet moving. How? Bullet was where? In the gun. Gun was where? With the police. Police was where? In the bus. In the bus. In the car. So ground people will see bullet moving. That velocity is not important for to hit the thief. So police should see the bullet coming out. So this velocity you have to understand is with respect to police. So they will ask find velocity of bullet with which it hits the thief. Matlab with respect to thief. Simple problem. Please try yourself. Like for the first, what will you find? Velocity of bullet from which frame? Ground. What's the formula? Velocity of bullet with respect to police plus velocity of police. Velocity of bullet with respect to police is 120, right side positive. Police is also going right side positive. Somebody must be thinking better police was at rest also, doesn't matter. 5 difference of 5 only. Better stand and shoot. Anyways, now what we have to find? Velocity of bullet with respect to thief. What is velocity of bullet with respect to ground? 125 right side. Minus velocity of thief 30. This minus doesn't mean thief is going this side. This is by default, I told. By default. Formula is what? VB minus VT. If this was opposite, I don't think thief will come this way. But if it comes this way, he wants to, let's say, I regret my mistakes. So then you have to put minus 30, then minus minus will become plus. So if you move in opposite direction, you will see it coming more faster. That's why this minus is very important. So now what is the answer? How much? 95 meter per second. Rain umbrella problems. Please focus. Rain umbrella problem. Let's start with basic question. Very, very basic. Rain is falling vertically down with velocity 4 meter per second. Man is running right side towards east, let's say, with velocity 3 meter per second. Question is, in what direction he should hold the umbrella? Now, where he should hold the umbrella? Where he sees the rain coming, or what ground people see the rain coming? Where he sees the rain coming. So, he has to calculate what? Rain velocity with respect to man, whose formula is VR minus Vm. So, you have to do minus of Vm, add with VR. So, VR is down. Add ulta of Vm. Vm is which side? East. Ulta of east is where? West. So, you have to add 3, but on the west side. Length will be 3 only, bro. So, who is this 3 if you want to know? Modulus of minus Vm. If you want to know, really know who is this 3. This is not modulus of Vm. It is modulus of minus Vm vector. Then you add those two. So, you will see rain coming this way. So, this is the direction of what? VRM. This is VR, no. Add minus Vm. Minus Vm means ulta of Vm. So, this is where the rain will come. So, you have to keep the umbrella at an angle of this much towards wherever you are running. See? So, if you are running east, you have to hold the umbrella towards east. What angle with vertical they will ask? So, that angle will be same as this angle. So, that will be what? Tan theta equals to opposite side is what? 3. Adjacent side is what? 4. So, theta is what? 37 degree. sometimes what will happen, rain will come with respect to, acha, this is velocity with respect to whom? Ground. This is with respect to ground. So here we want relative velocity. So you have to subtract. Sometimes what will happen, rain itself will come at some angle. Rain will come at some angle. Rain will come at some angle. Too fast rain this is. It's okay. Why rain will come at an angle? Maybe wind is there. Maybe wind. So if wind is this side, ground people will see rain coming this way. Now there is a man. Question is, in what direction man should run? Arrow I cannot show you right now because direction also you have to find. What should be velocity of man so that for him the velocity of rain with respect to him should be vertical. Ulta of this, you understood? For ground here rain was coming vertical, for him it was coming at angle. Now what I did? Ulta. Rain is coming at an angle for everybody, but for him it should come vertical. So let us assume man is going this side. Good option or bad option? Bad option. Because if man is going this side, ulta you have to do to this. Ulta you have to do. If man is going this side, let us assume, then what will be rain velocity with respect to man? This is rain velocity already given. Ulta of this will be what? This. Or you can add here also. This is ulta of man's velocity. So what will be the relative velocity? This one. It will become more angle. So rain velocity is this side. If you assume man is going here, reverse this. Add with this, you will get here. That is not what question told. If you do that, it will come even at more angle. That they can ask. How much fast he should move so that the rain comes at 60 degree. Then you have to do that way. But in this problem, what I should do? Man should not run that side. Man should run which side? This side. Now what will be the answer? How will I do now? This is whose velocity? Rain's velocity. I have to add ulta of this. Ulta of this will be where? Here. How much I have to add? Exactly this much only. This is minus Vm vector. Now if I add this one with this one, where will be resultant? This one. Matching with this or not? This was given how much? 30 degree. So now how to find what we have to calculate? Vm, this is the magnitude. So tan of 30. This magnitude is Vm. Oh no, this Vrm we don't know. So tan 30 will not help. What I should write? Sin 30. Sin 30 will be what? This magnitude is man's velocity in magnitude divided by hypotenuse is whose velocity? Rain's velocity. Sin 30 is half, man's velocity is Vm, rain's velocity was 10. So man's velocity should be 5. And where it should be? If rain is coming this way, he should run this way. They will say rain is coming at some angle, let's say 2 root 2 meter per second at angle 45 degree. This is rain's actual velocity. Actual matlab with respect to ground. Okay. And man is walking up the plane like this with velocity 5 meter per second, whose inclination from the horizontal is 37 degree. You have to ask where he should hold the umbrella. Now directly if you reverse man's velocity and add little bit complicated, it will become. It won't be a nice right angle triangle. So angle won't be easy to find. So instead what we will do, we will take help of components. So we will first write velocity. First we will choose positive x here, positive y here, like standard way, and then we'll write range velocity first. Take components. So this will be 2 meter per second, but remember cos 45, because tomorrow this will be 30 degree. Then this will be v cos 30, and here what will be the velocity? 2 meter per second. All of you understood? Vr cos 45, Vr sin 45. So what are the velocities of rain? Minus 2 I cap, minus 2 j cap. Minus 2, minus 2. Now tell me man's velocity. Man will have two components of velocity like this. This is 37, means this is also 37. So this component will be how much? 5 cos 37. Cos 37 was how much I told? 4 by 5. Because 37 opposite is 3, no? Adjacent is 4. So cos 37 is 4 by 5. So this is 4. And this component is 5 sin 37. So sin 37 is 3 by 5. 5 cancel. So what is velocity of man in vector form? Minus 4. This is 4, no? Why minus but? Opposite to x-axis. So minus 4 I cap plus 3 j cap. So now I want whose direction I want? Velocity of rain with respect to man. Vr vector minus Vm vector. Subtract. Direct subtract. What is there? So minus 2 I cap minus 4 I cap 2 I cap. Minus 2 I cap minus 4 I cap. So plus 4 I cap 2 I cap. Minus 2 j cap minus 3 j cap minus 5 j cap. So this is the direction where I have to keep the umbrella. Now how to mention in angle? Simple. Draw this vector. X is 2. Y is minus 5. Y is minus 5 matlab down. Length will be what? 5 only. So where is the rain coming? It is coming in this direction. For whom? For man. So where he should hold the umbrella? At this angle, which is same as this angle. So what will be tan theta? Opposite by adjacent, 2 by 5. So he should hold the umbrella at what angle? Tan inverse 2 by 5. But in which way? He was walking this way, no? So he should hold 30 this much angle from vertical towards this side. So west side. See this question now, very interesting. So when man is running this side with velocity 10 meter per second, let's say 3 meter per second, okay, rain appears to come this way. This is rain's velocity with respect to man at angle 30 degree. And when the same man is going this side with 5 meter per second, he sees the rain coming this way at 45 degree. You have to find actual velocity of rain. Find actual velocity of rain. Actual, by actual what they mean? With respect to ground. There is nothing actual about ground frame. To be honest, ground itself is moving with respect to sun. Right? So what is actual about that? Anyways, let's do the problem assuming ground is at rest. Now how to do this problem? See, whenever they will ask actual velocity of rain, because rain's actual velocity doesn't depend on whether this person is going here or going there. This will be affected by that. Where he will see the rain coming, that will be affected by his velocity, which he has with respect to ground. But rain's actual velocity from ground frame doesn't depend on what the man is doing. Therefore, what we will do first thing is let Vx, Vy be components of rain velocity. That's the first thing I will do. I don't know where the rain is coming because that's the question. But I know wherever it is coming, it will have some x component, some y component, right? So this is the x component of the rain and this is the y component of the rain. It will be down obviously. Rain it is. Case 1. Where is the rain coming with respect to man? 30 degree at vertical. How to get this vector? Add to this. Who is this vector? Who are this vector? Rain velocity. This is rain velocity only. No, Vx I cap plus Vy j cap. Okay, minus Vy j cap. If Vy is positive. Minus I wrote already. So if this is rain velocity, how will I get rain velocity with respect to man? Ulta man velocity. Reverse man velocity. So 3 this side ulta. But let me mention this is minus of man's velocity modulus. Because I wrote 3. What? Let me not write modulus also. I hope you guys understood. This is whose velocity? Rain's velocity. What is this? Reverse of man's velocity. Now if you add this 3, what will you get? This velocity. Now who will be this? Because you see rain is coming this way. This should be greater than this. So resultant of these two will be what? Here 3 minus Vx. And this is Vy. And that will be your rain velocity with respect to man. And that is given 30 degree with vertical. So tan 30 will be opposite by adjacent. Equation 1. I need one more equation now. That will come from second case. Case 2. Again, actual velocity will not change, I told you, of rain. Now, where is man going? 5 meter this side. So, I have to add reverse of that. Reverse of that matlab here only. 5. So, that will give me Vx plus 5 and here Vy. And where the person sees rain coming? This way. So obviously this resultant, these two will be there only. So resultant will be where? Now, here, who is this? Velocity of rain with respect to man in the second case. Second case. And what this angle they gave? 45. That means tan 45 should be what? 1 to I know, ma. From here I am asking. Trigonometry I am doing class 10. Tan 45 is what from here? Vx plus 5 divided by Vy. Can you now solve this too? Can you solve? What you should do? Divide those two equations. If you divide Vy, Vy will cancel. Let me do it for you here. So equation 2 divided by equation 1 you do. On the left side of equation 2 is tan 45, which is 1. On the left side of I did equation 2 by 1. No, so equation 2 left side is tan 45 1. Equation 1 left side is tan 30. What is tan 30? 1 by root 3. Vx plus 5 divided by 3 minus Vx. Clear now? So this root 3 will go up. Vx plus 5, 3 minus Vx, cross multiply 3 root 3 minus root 3 Vx equal to Vx plus 5. Numbers are not coming nice, but that's okay. So if I take this one that side, 5 this side, 3 root 3 minus 5 is equals to 1 plus root 3 Vx. So what will be Vx? 3 root 3 minus 5 by 1 plus root 3. That is Vx. Now put this Vx there and find Vy. Let us not do that. Man is walking this side with 2 meters per second and he sees the rain coming this way. Okay, first case. Then in the second case, man is walking this side. I don't know. Three meters per second. And he sees the rain coming this way only. He sees the rain. VRM. This angle is, okay, let me write 5. And this is 53 degree. Just to make numbers easy. So you have to find again VR vector. You have to find actual velocity of rain. Again, whenever such questions they give, what I should do, I told, let Vx comma Vy be the components of VR vector, and these components will remain same whether the man is moving, not moving, doesn't matter. So now in case 1, this is Vx, this is Vy, am I right? I have to add reverse of this. Reverse of this will be where? Here. Now they told this is the whose velocity. Now this was rain's velocity. After adding this is whose velocity? Rain's velocity with respect to man. Where is that velocity they told? Vertical. Now if the total of this is vertical, it means Vx has to cancel to. Simple. So Vx we got. Vx already we got. Now one understood. So if the rain velocity is this side, these two has to cancel. Now sometimes what may happen? This may be going this side. Then you will reverse that. When you reverse that, it will become Vx plus 2. So Vx plus 2 has to be 0 means what? Vx has to be minus 2. That means rain is actually coming this way. I mean rain's actual x component of velocity is this way. Vx is actually this way. So assume Vx and Vy and solve. If Vx comes minus, it means actual Vx is this way. If Vy so we have taken down only positive. We have down only, we have written Vy. So if it comes positive, it is down only. If this comes negative, which is hardly possible, rain comes up, you have to put umbrella like this. So this should not come up. So case 1, see, immediately from case 1 what I got? Vx. Now case 2. This is Vx, this is Vy. Now I have to add whose velocity? Ulta of man's velocity, but man is going at angle. So let us take first components. So quickly tell me, these are the two components of man's velocity. This is 53, so this is also 50. Yes, 53. So this component will be what? 5 cos 53. Cos 53. Opposite of 53 is 4. So cos 53 will be 3 by 5. So this will be 3. This will be what? 4. 5 sin 53. So I have to reverse these two. So reverse of 4 down is where? 4 up. And reverse of 3 right side is what? 3 left side. Now, who should be bigger? How will you know? Because these two are unknown. So how will you know who is bigger? See where the rain is coming. This way. For him. So its component should be here and here. So this one should be bigger. So this can be converted to what now? Here Vx minus 3. Here Vy minus 4. So if you add those two, you will get the rain velocity with respect to man in the second case. And where is that they told? 53 degree with horizontal means 37 degree with vertical. So with vertical it is coming at 37 degree. Or you can keep this one only 53. What is there? Rain is coming with horizontal 53 degree, right? According to that diagram. 53 degree. So from here what will be your sin 53? Tan 53. Opposite of tan 53 is Vy minus 4. and adjacent is Vx minus 3. Tan 53 was how much? Opposite of 53 is what I told, 4. So 4 by 3. Vy minus 4. Vx we found already, no? Vx is how much? 2. Can you solve this? How much we get? 8 by 3. Everybody got 8 by 3? Okay. So what is velocity of actual rain? 2I cap plus how much you told Vy? 8 by 3. So plus or minus ma? Minus. Minus 8 by 3 jk. Minus, okay students, because it is down. So that is the vector form. Now magnitude of rain's velocity, if they ask, root over 2 square plus minus 8 by 3 whole square, you do. Finished. Now you can give the actual angle where rain is coming also. Actual angle with, where rain is coming also you can give. Because this is 2, this is 8 by 3. So this is the actual direction of rain. And this angle you can find. Tan phi equals to 2 by 8 by 3. See students, if you know vectors components, you should be able to find magnitude, you should be able to find direction, matlab angle. Either with x axis or y axis, that is your wish.